Hey everyone, once again, sorry about the delay. It looks like we just got kicked out. We're just waiting for Srikar to come back.
Yep, I'm back.
Oh, perfect. I'm so sorry. I don't know what happened, but
All good, no worries.
okay, you're good to go now.
Hey, welcome everyone. Looks like we don't need any icebreaker now, but well, thank you all very much for taking the time to join with us today. I'm super excited to facilitate this workshop and hope that it brings you and your team some sort of value, and hope that you learn something of use by the end of your time here today. Let me start off by introducing myself. Uh, so my name is Srikar Kovvali, and I'm a senior data scientist at DataVector AI, specializing in supply chain automation and machine learning. I recently worked at Tesla's Fremont facility as a full stack supply chain engineer, working on the supply chain automation team. I'll be discussing some of the supply chain tricks and tips that I learned during my time there throughout the workshop. In addition to working at Tesla, I also spent a year and a half working on various teams at PayTM Labs in Toronto, Canada. PayTM are one of India's largest mobile payment platforms with more than 300 million active users a day. Working at PTM taught me a lot about working with scale and operating with extremely large amounts of data, especially in the process of extracting vital information and searching for hidden patterns within data sets. Before my stint at PayTM, I also worked briefly at KPMG with the global research team doing data sampling and analysis. In my current role, I lead DataVector's machine learning and data science operations in supply chain automation, focusing especially on scaling automation architecture as well as predictive analytics. So we at DataVector are the only cyber alt data provider tracking real-time cyber policy governance and resilience risk scores. We're working on providing our clients with insights in their supply chain framework and also having them achieve more resiliency in their logistics and cyber infrastructure. So enough about me. Coming to the actual workshop we have in store for you today. We all know how COVID has impacted the world. The economic repercussions caused by it will be felt for a long time and for years to come. All of us today have either directly or indirectly been affected by it and will continue feeling its effects for long after. So here's a brief overview of what we'll cover in the workshop today. For those of you who are new to the world of supply chain, we're going to first take a look at supply chains in general and the impact COVID has had in disrupting them. Then we're going to dive into some reference MLOps architecture for supply chain and look at some techniques in improving resiliency. After that, we're going to have you open up the data sets we've provided you with and follow along in creating your very own supply chain model. We're then going to take a short 5-minute break after the exercise and then return to looking at some post-COVID MLOps for supply chain AI. After, we'll be exploring some of the relevant data sets and use cases of what you've learned here today. We're then going to round up today's workshop with some information about how to continue to monitor and manage your supply chain models and look at connecting them to external endpoints to better integrate with your flow. Before I get started, with me today, I also have Eric Buckingham, who is the CEO and founder of DataVector, as well as Nicholas Garkulitz, who is a solutions architect at one of our partners, DataIQ. We want today's workshop to be as interactive as possible, so please do not hesitate to ask us any questions. We'll be monitoring the chat throughout the workshop. Additionally, we'll have a small Q&A session at the end where you can ask us further questions regarding what you've seen today. So can I get a thumbs up from everyone if we're good to go? Perfect. So what is a supply chain? A supply chain is essentially a network between a company and its suppliers to produce and distribute a specific product to the final buyer. A supply chain is usually defined as an entire process of making and selling commercial goods, including every stage from the supply of materials and the manufacture of the goods through to their distribution and sale. Successfully managing supply chains is essential to any company hoping to compete in the market today. This network could include different activities, people, entities, information, and resources. The supply chain also represents the steps it takes to get the product or service from its original state to the end customer. Ill-managed supply chains tend to be cash burners, but when managed appropriately, supply chains can reduce the total cost of ownership of supplies when there is neither too much surplus nor there is backlog, creating an efficient kind of state in the middle where it's like a well-oiled machine. Coming to supply chain management, SCM is the base term that covers product development, sourcing, production, procurement, logistics, and more when it comes to operations in the supply chain. Without it, companies usually run the risk of losing customers and also run the risk of losing their grip on their vertical to their competitor. The supply chain operational model can be broken down as follows, or rather into like 5 distinct major processes. The first process is planning. These are the processes that balance, aggregate demand, and supply to develop a course of action which best meets sourcing, production, and delivery requirements. The second stage is sourcing. These processes are those that procure goods and services to meet planned or actual demand. The third step is making. This process is the one that transforms product to a finished state to meet planned or actual demand. The fourth stage is delivering. This is probably the most key stage. These are the processes that provide finished goods and services to meet planned or actual demand. These typically include order management, transportation management, and distribution management. The fifth stage is somewhat unwanted. It's a case where we don't want to go into, but the reality is that it happens. And this is the return stage. We need to have an efficient return system in our supply chain so that the processes associated with returning or receiving returned products for any reason extended to post-delivery customer support. So
hi, Srikar, are you sharing your screen? I don't think we're seeing your screen, Srikar.
Let me. Oh, I'm sorry. Once I came back in, I don't think I shared the screen. So we can
That's
just
fine.
go through the slides really quickly once again. Can you guys see my screen now?
Not yet.
Can you guys see my screen now?
Not
We're
yet.
still seeing your video. Oh, there we go.
Okay, we see it now.
Perfect.
Perfect.
Apologies for that. I didn't realize. Yeah, so going back into the 5 stages of supply chain management, these are the planning, sourcing, manufacturing, productivity, delivery and logistics, and the return system. The goal for us in supply chain management is to be proactive instead of reactive. We need to mitigate the risk by identifying the pain points in our supply chain. And these could include both physical and virtual supply chain risk objects. Going into the digital age, we all know that everything isn't just the physical supply chain. Digital supply chains are as influential and critical to our processes today as virtual supply chains, and they should be working in tandem. One important point to note when assessing your supply chain is not only to create processes that are efficient, but also managing them. And this is where supply chain management comes into play. These are today's top supply chains. As you can see, there's big systems like Cisco, Colgate, Johnson & Johnson. Basically, huge conglomerates often have really huge supply chains that scale from different verticals. And it's essential as we are all part of the MLOps environment, it's essential for us to monitor these and look for patterns and look for, analyze our patterns. So why supply chain AI? In a 2018 research paper, McKinsey identified supply chain and manufacturing as one of the 2 main areas of impact for AI, along with marketing and sales. The firm estimated that the unlocked value of AI for supply chain and manufacturing to be from 1.2 to 2 trillion USD. The ever-increasing adoption of artificial intelligence and machine learning across a variety of industries is evidence of the transformation and tangible business impact that these technologies are having today. And combined with the potential they provide, when integrated responsibly and transparently, these can provide huge value to your business. One sector in particular that is experiencing growth in incorporating AI is supply chain management. From predictive capabilities for optimized demand planning to autonomous vehicles and warehouse robotics, stakeholders across the supply chain will continue to harness a proliferation of data sources and technology that enable them to cut costs, accelerate profits of all sizes and across all industries. Most of the time when I'm like out, people ask me like a question, what's the difference between a machine learning model and AI? The main difference between a machine learning model and AI is that it's in the design of the service that uses the prediction. Business artificial intelligence uses the machine learning model to automate an action. The current data analytics initiative is mainly implement data science proof of concepts. The automation part, which relies on an algorithm, is difficult because of the feedback loop. Every automated action taken needs to have a feedback loop that tells if the action taken was relevant or not. It is just like when a human makes a decision. If it's a wrong decision, a boss or a master will tell it that. With AI, on the other hand, the boss is the final user, which could be a client, an operator, or a collaborator. Moreover, to be, in an automatable concept, the process must be perfectly simple. If exceptions occur too frequently, many decisions cannot be learned and future mistakes will be made. So COVID is essentially the hottest topic. Everyone's been talking about it. I know everyone's sick of hearing it, but you guys are here today to look at the impact of COVID on supply chains. So here we are. China essentially affects everything, which is why we need to have diversification in our supply chains. Diversification is key. In today's unsettled times, the companies who have spent time to invest in artificial intelligence or risk identification systems will fare the best when we come out of this situation simply because they were not impacted as much. In addition to having a top-level view for supply chain infrastructure, it is essential that companies do not put all their eggs in one basket. In particular, Wuhan, which is a manufacturing hub, has over 200 of the 500 Fortune 500 companies present. In addition to that, a sizable portion of the Fortune 1000 have their main suppliers in Wuhan. So you can see how one pandemic or one incident somewhere in a country far away from us can have a global impact. And this is partly due to globalization. And we can debate about if globalization is a good thing or bad thing, but a lot of companies recently have been reevaluating their supply chains and reevaluating their globalization structures and are moving to a more local standpoint. But either way, a supply chain will remain throughout, which is why it's vital for us as supply chain engineers, as MLOps engineers, to look at supply chains from a top-level view and analyze every single risk aspect. So why do we have the need in logistics for supply chain and AI? Basically, we at DataVector provide a holistic solution for identifying risk. And it is essential for every single company out there with a supply chain to identify risk both in their virtual and physical supply chains. By identifying risks, you mitigate them. And using AI, you're able to essentially allocate resources to other things in your stack instead of working on using your resources to develop in maybe AI or machine learning. You can allocate those resources into development, app development, other ways, right? Why the need? A good example for cyber and logistics and supply chain AI is the Maersk attack. So basically what happened in the Maersk attack was, and Eric can pitch in here as well. The Maersk attack.
Yeah, sure. I can talk about this. So what happened a couple of years ago was Maersk, which is the container shipping line that moves most of the products from Asia to the west coast of North America and every other place, was hit with a massive malware attack. It took down all their computers, all their servers. Long story short, they were down for 10 days. Their stock took a massive hit. So this sort of evidences the fact that the virtual supply chain is just or even more important than the physical supply chain. And like Srikar just mentioned, we have to take those virtual risk objects in the supply chain into account when we're creating models.
Now we can look at supply chain MLOps. Basically, MLOps is the process of collaboration between data science and engineering teams, along with supply managers to accelerate and ameliorate the machine lifecycle across various aspects of your SCM. In our workshop today, we're going to be looking at how to integrate MLOps within your chain and also look at other data science tools. The essentials for having good MLOps infrastructure, not only in supply chain, but in general, are 4 principles that you should essentially remember. Simplified model deployment, machine learning monitoring, production lifecycle management, and production model control. MLOps helps ensure that deployed models are well maintained and performing as expected, and make sure that they don't have any adverse effects on the business. This role is crucial in protecting the business from risks due to models that drift over time or that are deployed but unmaintained or unmonitored. At a time when issues like responsibility and bias are at the forefront, MLOps becomes even more important to close the feedback loop between operationalized models and their impact. Given here is some supply chain architecture. This example is taken from Microsoft, which covers basically every point you should connect in your MLOps framework. We can think of our MLOps framework to have 5 layers. The first layer would be partners. This layer holds all the partner systems that you integrate with and onboard into the supply chain. The second layer would be marketplaces. This layer is an interface between partners and the supply chain to trigger workflows and actions. These include service edges as well. Service edge would be a third layer. The service edge offers overarching integration between the marketplaces, partners, and core supply chain services. Third-party investigators are also a part of this layer, specifically for retail relationships that involve a large volume of message translation. The fourth layer would be ERP and processing layer. These include transactional systems. All business processes and supply chain capabilities are enabled here to process supply chain transactions. This layer has the core supply chain processing components that any company should manage internally. The fifth layer would be data warehouse and analytics. This layer is responsible for the data processing and analytics to derive business metrics and key performance indicators like KPIs. Does anyone have any questions at this point, or do you want to share anything about your supply chain and your experience with supply chain? We want to make this as interactive as possible, so please feel free to pitch in.
Can you indicate on this graph, like what are the different layers? Oh wait, I guess I can't see what the layers are because it's all in this cloud diagram because you said the third layer is the service order updates.
Yeah. Then the fourth layer would be ERP and processing, and then the fifth layer would be warehouse and analytics.
Okay.
The diagram here essentially is helpful for seeing a top-level view, where essentially every single company needs to have a top-level view, and this is an example of what Microsoft uses. This is how they're monitoring their supply chain with the manufacturer, warehouse, logistics, retail, and their external endpoints, right? And the 5 layers are just a good practice to have to keep your supply chain system in check.
Okay.
Will you be circulating the slides afterwards so we don't spend too long trying to negotiate the individual detail in the slides?
Sure.
Yes.
Thank you.
Now that we have a lot more context about supply chains and COVID's impact on it, as well as a general understanding of good MLOps principles when designing and building supply chain automation infrastructure, we can finally get to what we really want. In our workshop, we're using data provided by the CFS, which is the Commodity Flow Service, which is the primary source of national and state level data on domestic freight shipments by establishments in mining, manufacturing, wholesale jewelries, and other retail services and trade. This survey essentially produces estimates on the type, origin, and destination, value, weight, modes of transportation, distance shipped, and a bunch of other metrics that you'll see coming up. It's good to have a data source that has a lot of metrics because then you can work with a more holistic view of your data. And we got this data set from Kaggle. It's completely open source, and you guys can feel free to research this online after the workshop as well. Today, we're going to be working with XGBoost. XGBoost is our algorithm of choice because the beauty in this algorithm lies in its scalability, which essentially drives fast learning through its parallel and distributed computing and offers efficient memory usage. XGBoost is essentially like an ensemble learning method, and it sometimes may be difficult to rely on just one machine learning model, but the benefit of using XGBoost is that it offers a systematic solution to combine the predictive power of, I guess, multiple learners. The resultant is this one model, which gives an aggregated output from several different models. If you look at the actual like machine learning algorithms, there's 6 different steps. The first level would be a decision tree. The second level would be bagging. The third level would be random forest. Fourth level, boosting. Fifth level, gradient boosting. XGBoost takes all these components in with them to provide one huge, powerful algorithm. And the testament to this is that XGBoost has won so many Kaggle contests. If you go on Kaggle and look at any of the data contests, more likely than not, you'll see XGBoost being used. XGBoost primarily performs so well because of its parallelization, tree pruning, hardware optimization, regularization, cross-validation, sparsity awareness. Basically, it's the go-to algorithm. So now if you guys could all go to the link we sent you, we can start the actual coding part of the workshop.
Hold on, is that the DSS link that you sent everyone?
Yeah,
like,
with the user and password.
Okay. What screen should we go to? I'm in the getting started.
If you can click on XGBoost SC, it should take you to the screen that I'm seeing.
Oh gosh, I'm in the home screen.
So you're probably in this screen right now?
Hold on, please. That's pretty much, no, see, I better hit the project screen.
If you could go click on the bird logo on the left, you'll come to the home screen.
Okay.
Your URL should have your /home after it.
Yes, I do.
Perfect. Do you see the project?
No, seems like I don't. Oh goodness, no, seems like I better get project or something, right?
The project should be titled XGBoost _SC.
Oh God.
Nicolas speaking from DataIQ. Would you be able to share your screen?
Okay, yes, I have it. I found it.
Perfect.
Okay, cool.
I just had to lower something down. Yeah, I just had to lower the getting started, but yeah, I'm gonna go to the XGBoost screen, and then do I have to go to flow or something, or where? Oh gosh, now I have another menu, navigate and help.
You will see a pre-built XGBoost Python notebook. That's with the completed solution. But if you could all go ahead and create your own notebook, in the top right corner, you'll see a plus new notebook. This will open up a new Jupyter notebook. You can just click on Python.
Click this. I just look at the discussion. Oh gosh. Oh God. Excuse me. I don't know if I'm a bit of an aberration. I can't find that. I'm in XGBoost SC and I got a sandbox here.
That's all good. That's all good. No, don't worry about it. If you can click in, can you see my screen?
Hold on. Let me. Yes, I do.
In my screen, in the top left corner, you see xgboost.c, right? So you click on this code thing right here, and the dropdown will have notebooks.
Okay.
Click on the notebook, and you should see one notebook that's there, XGBoost Python notebook.
Okay.
That's the completely built notebook. What we want to do is click on a new notebook. So each individual should be clicking on a new notebook and creating a Python notebook.
Okay, I have this. Do I have to give it a new name? I have to say you have to get your own login notebook, like I have user 2's notebook. Should I just click create now?
Yep. Is everyone in the Jupyter notebook? Can I get a thumbs up?
Do we have to import any spreadsheets or anything, or?
I'll give you the import. So just if everyone's ready and good to go, we can start the coding part of the workshop. So
I just have a quick question. For the Python environment, we have two choices. One is the built-in environment, the other is training. Which one should I choose, or it doesn't really matter?
Doesn't really matter. You can use built in.
Thanks.
I'm going to be coding the entire model from scratch right now, but if you guys want to, whoever is a bit more tech savvy, can go ahead and open global shared code, and you'll find the entire workshop code here, which you could play around with. But if you want to follow along with me, you could do that as well. Both work. So again, if you can go to shared code, global shared code, the waffle thingy on the top right, you'll see the Python file for today's workshop that is completely built. And you can play around within Jupyter notebooks, but I'll be building this from scratch and explaining what each component of the code does. Okay, we have 9 notebooks on the first instance.
Seems like I can't find global. Oh, wait a minute.
The waffle thing on the top right.
Okay, the top right. Okay, notebooks and memory. Oh. Okay, the global shared code, the box.
And then you'll see workshop.py.
Hi, Srikar, could you enlarge your screen just a little bit?
Sure.
Thank you.
Is this better?
Yeah, that's quite large. Thank you.
Great. So I'm assuming we can start. So basically, we'll first go through our import statements where we'll import all the libraries that are necessary. You can import them, copy paste them from the file that we have given to you in global shared code, or you can type it out, whatever works for you. So these are the libraries that we have. Essentially, we're starting off with the scikit-learn models for our regression score, accuracy score, as well as the importing the XGBoost regressor from the XGBoost library. That's probably the key library that we're using today. If you want to replicate this on your own machine as well without DataIQ, you can feel free to do that as well. This works well because it's a shared environment where we can give you the resources, which is why we're using this platform today. In Jupyter Notebooks, if anyone hasn't used it before, we can run each section of code, which is really helpful because you can see, you can essentially compartmentalize your code to see what works and what doesn't. So if we can all click on run after we've copied, we should see that the import statements have been loaded. So essentially our problem description here today is to predict a regression supply chain score for one of the metrics on our data set that we'll see in a minute. We must the first step for any machine learning platform is to load the data, right? So to load our data, I've already provided you guys with the cleaned sample data set, and you can load the data using this code right here. It's a CSV file that we got from Kaggle. And so after the loading step is done, we can then split the data. Why we split the data and why it's important is because when we're working with a singular data set, what we need to compare is the pre-data and the post-data. For example, in this piece of code, we can see that we have split the data set 100 lines for pre-COVID data, and then we have the post-COVID data, which we're gonna run the train model on with another 100 lines. The data set that I provided you with is actually really huge. It has about 1 million different data points, but we're only using a sample size of it. If you want to play around, you can increase the data set size to basically 100,000 if you want to explore that. But we'll be sticking to 100 just because we don't want to run into any memory issues today. Once we split the data, we can check for the validity of the data.
If you want to use, and Nicolas speaking from DataIQ, if you want to use much more than 100, you can push like 100,000. Okay, not 1 or 10 million, but at least you can have 100,000.
What we're essentially doing in the pre and the post.head is essentially having a view of what the data looks like. As you can see, we have a bunch of different parameters, all integers because XGBoost won't work on non-numerical values just because it can't. And this is the initial data set that we see for the pre-COVID. And then we can see the second split of data in our post when we run it. Please let me know if I'm going a bit too fast. I can definitely slow down.
So just as for background, what's our objective we're trying to achieve with the coding here?
The objective is to essentially use XGBoost to look at each different variable and get an overall regression score from it.
And so from a business standpoint, the objective would be?
From a business standpoint, the objective would be to learn more about your data, right? The more you know about the data, the better you can get at using it. As a data science team, as an MLOps team, our job is to provide the business side of business teams with insights, right? And using a machine learning model like XGBoost would essentially provide you with the best insights of each one of these variables. For example, we can pick any of these. For example, if a business client, or if your business team wants to know trends in origin state or trends in shipment value, we can use this model to see before COVID and after COVID what the shipment value regression is like. Is it in a positive slope? Is it a negative slope? And that would help us that would help like the business side, the business teams, it would give them more insight into what data we're seeing and what the implications of COVID really are. This is just the example data set, right? We could use any data set with this model. It's a pretty standard model for machine learning where we split the data set. But with real-time data, of course, it's going to be a much better model where we have real live data.
Do you mind explaining some of the fields? What does it mean?
Mm-hmm. So in this data set, we have shipment ID. It's just the internal shipment tool, shipment label. The origin state is actually a state map number. So in each state in the US, there's essentially 53 different values here that are associated. And this gives you the parameter of seeing from which state to which state is this particular package going. If you want, I can post the actual values of the headers on chat for you guys to see and get a bit more context.
Thank you.
So are you regressing over a time series here, or are you looking at each of these variables across the horizontal?
We're just looking at each of the variables across the horizontal.
Okay.
But we could do time series, but for the purpose of this workshop, I didn't want to make it a bit too complicated. So we're looking at individual variables now, but you could definitely use, and actually we're going to look at time series later on as well. So I've put up the actual headers on my screen here if anyone wants to see the actual header titles. For the purpose of using XGBoost today, we've eliminated a few of the columns, which is why you don't see every single value in your data set right now. But if we're using any other model like L2 regression, then we don't need to eliminate the other columns. So once we look at our pre and post data, and once we set it to whatever value you want it to be, we can then split the data into training and test sets. For the test size, it's essentially using a parameter for what value of your test that you want to use. That could be any value, essentially.
Hi, it's Eric here. Just wanted to get a little bit more specific around the business problem questions. So the business problem that we're solving is basically with this model output, we're identifying which factors influence disruption in the supply chain model, in the supply chain itself. And we're also determining if shipment values have any impact on supply chain disruption, and if we can predict the value of a shipment.
Okay, thanks very much, Eric.
You're welcome.
Once we get that in, we can essentially pick what parameter we want to analyze on. I've chosen to train and test on weight factor, but you guys can go ahead and pick your variable of choice. In step 6, I forgot to mention, we also specify a seed for the random number generator so that we always get the same split of data each time this particular example is executed. So the two parameters would be seed and test size, which you can change as well. And then we can fit our model to our training data by associating the model variable to the XGBoost regression that we imported, and then fitting the model onto the X and Y sets that we just trained. With XGBoost, it provides a wrapper class for us to allow models to be treated like classifiers or regressors. In this particular example, we're using regression because regression requires the prediction of a quantity. It attempts to predict like a value from an input based on past data. With classification, it's the task of predicting a discrete class label, and predictions are made by classifying them into different categories. But for this particular example, since we're working with one variable, we're going to be using regression.
Excuse me, I got an error when it says that it doesn't recognize the word pre-trained. I use that in line 6. I had the exact command that has, but for somehow when I ran line 7, it said it didn't recognize it, or it wasn't. I got an error.
Could you share your screen with us?
Sure. Oh wait. Oh, I gotta share my. Oh, where's okay? Oh, it says I can't share while you're sharing.
Sure, I can hop off.
I think it's over here. It says pre-train is not defined. Oh gosh.
I think it's because you haven't run the command with the seed 7. So if you can click on run.
Okay. I thought I ran everything.
It will execute, and now try running the one below it. There we go.
Yes, it's fine. I mean, I set it to run everything at once, but.
With the run command in Jupyter Notebooks, it doesn't run the entire thing at once. It runs each code block. So every time you type something in a different code block, it's best practice to run each one.
Okay, I tend to run all, but I guess that's something I know for the next time.
So once we fit our model to our training data, we can then make predictions on our training data.
Sorry to interrupt. Will you be covering continuous integration in this part?
Not in this workshop today, unfortunately.
Yeah, thank you.
Then we can go ahead and run that. Can I get a check if everyone's on track? Any other questions? Am I going too fast or too slow? I can adjust my speed to whatever you guys want.
That's right.
Once again, the entire code is available in shared resources, so you could jump ahead if you want and experiment on different parameters if you've already compiled the entire piece of code, but I'm just gonna hold off a bit and let people explore.
A quick question about post and pre. We're using only I guess pre-test and pre-train. Why we're not using post for the evaluation for the last step? Like you see, we assign all like Y train, Y test, and we're using everywhere pre-train, pre-test for both of them. The question.
We're just associating the variable.
Yeah,
here, right?
yeah, this one. Why we're not using post train here for the test variables?
I think that's the data index, I guess, the pre-test which they have been using, and they have finally indexed the data. Is that right?
Yeah.
Yeah.
And then the final step for us would be to evaluate our predictions using the regression score. And when we run it, we should be getting a regression score. And depending on what values you guys put into your data set and the size of it, that value would change. Some of you may be wondering why we have a negative regression score here. Essentially, regression coefficients are estimates of unknown parameters, and they usually describe the relationship between a predictor variable and the response, right? So in linear regressions, coefficients are values that multiply with the predictor values. So for example, if we have a regression equation, say y equals 3x plus 5, in this equation, we'd have plus 3 be the coefficient, x be the predictor, and plus 5 would be the constant. So the sign of each coefficient indicates the direction of the relationship between a predictor variable and the response variable. A positive sign would indicate that the predictor variable increases and the response variable also increases, whereas a negative sign indicates that as the predictor variable increases, the response variable decreases. And this would give you a good estimate while testing on your data to see the regression score will give you a good idea of what kind of changes there are in the variable of what you're testing for pre-COVID, post-COVID. Can everyone give me a thumbs up if they're good? If you have any questions, please do speak up. If you want me to go slower, you can always tell me to go slower as well.
How else would you go about playing with the code that you just built? You pointed out a couple of ideas. Is there anything else to, I guess when you're newer at this, you just want to kind of rip it apart and poke it. I can't put it in a better way than that. Is there any other way that you use either this particular platform, but really to get into the code and play with it?
DataIQ itself, yes. We'll be looking at some further machine learning models that we can see and further. There's a lot more use cases that we'll come to, but in this particular model, I wanted to keep it a bit more simple just for the sake of everyone. But like you said, we could do regression classification on XGBoost itself, where we could pit two variables against one another by creating another training set. We could do multiple training sets. We could join the data sets, right? We could do a lot more with this base code. But we'll be looking at further, I guess, algorithms in a bit.
Hi, Srikar. It's Eric here. It looks like we have a question on the chat.
Yep, we can share the scheme of data set. The 5-minute break's coming up in just 2 minutes, just making sure if everyone has gotten up to this stage, we can take the 5-minute break, but we can see if we want to go into the data set itself, if you can come out of the Jupyter Notebook environment into the home screen of DataIQ. In the bottom left corner here in blue, you will see data sets, or you could even go to flow, where you'll see something like this, where we have done the background work to prepare the actual data set. So you can see the initial data set by clicking on this blue box. You can see the sample data set after sampling and cleaning in the prepared run. This prepared data set is what we're using on our Python or Jupyter Notebook, but we could always replace that with this if we want to explore other parameters. So once again, go back to the home screen. You can click on the main project, go into flow in the top left corner, and you'll see the data sets themselves. And if you actually want the full data set, you could go to Kaggle. This is where we got the actual data set from. It's the US supply chain information for COVID-19. It's a fairly large data set, so as we can see. I hope that answered your question.
Yes, it does. Thank you.
Perfect. We'll just give a couple more minutes for everyone to wrap up, and then we can go take our 5-minute break. Hey, Rena. Yep, we're gonna do a complete demo of what we've just seen in Jupyter Notebooks using DataIQ, which completely makes it easier for us to deploy and implement machine learning models. We'll have that for sure. Great, I think we can restart this session. So now that all of us here now know how to build our own basic machine learning model, we can go ahead and take a look at some useful data sets for supply chain modeling. Not all of us are working with such data and scale that we have for appropriate machine learning models. So these are some good data sets that I found personally to test and retrieve sample data. We have the global garment supply chain data, pretty expansive with a bunch of different consumers, as you can see, Target, Sears, JCPenney. We also have the supply chain shipment pricing data set, also pretty comprehensive, coming from the Global Fund. Other data sets include real world multi-echelon supply chains, and also this one from the Bureau of Transportation Statistics. I'll be linking these down in the chat in a minute so that you guys can take a look at them at your own time, maybe use a model you have today to test and explore. So now that we know a lot more context about supply chain and the AI models, here are some post-COVID use cases that could come in handy. The coronavirus has, of course, presented unique challenges to supply chains worldwide. No one was expecting this, and a lot of data science teams actually became redundant after because they didn't have the proper models for a COVID use case. So again, being proactive instead of reactive is a big plus point in supply chain AI. As cities and states rise to meet challenges, it's important for us to know where critical items are produced, and essentially we need to have a top level view, as I've said before, of our supply chain. This can be especially useful in current scenarios for manufacturing capabilities, medical devices, pharmaceuticals. Some particular use cases for supply chain AI would be in, say, the logistics route optimization. To, say, reduce the cost of shipping and make the shipping process itself faster, you can use AI to decide on the best routes. This is especially important in the case if you're a large e-commerce company with a lot of consumers. They're always happy to get their orders as soon as possible without any delays. Any AI that we use would help analyze the existing routing, do track route optimization, and therefore you'll be able to reach better results and bigger profits. We could also use this same model in predicting peak hours using AI in logistics centers, or say supplier selection and supplier relationship management. A key use case that I've worked with is of course in autonomous vehicles, AI in logistics and shipping. Logistics and shipping are pretty obvious things when we're talking about the supply. In most cases, goods have to be somehow delivered to the customer, contractor, or whoever else. And here we have a lot of restrictions. For instance, drivers are only allowed to drive nonstop only for a certain amount of time. After this, they have to take a break or be replaced by another driver. And organizing and managing all of those things are really good use cases for AI in the supply chain. A post-COVID model could look something like this in Dataiku. This is a more comprehensive model using the Dataiku capabilities that we're going to see in a minute. Dataiku is a pretty unique visual platform that enables us to essentially do modeling without the use of any code. So all the Jupyter Notebook Python code that we saw right now isn't really necessary. We can simply create visual models like this. For example, in a post-COVID dataset model, we'd have the same initial steps of choosing your data, sampling it, joining datasets for what you want to search on or what you want to compare, and then training your model on, say, the pre-data join, like we can see here, and applying different machine learning models like isolation forest, regression, and deploying them onto your post-data join. So this is a pretty good representation of any pre to post, be it COVID or any other comparison that we're doing using classification. This is a good model to follow, which gives you a lot more context and view in your output data. Going further, we could also talk a lot more about implications of cross join versus left join versus inner on the outcome of machine learning. We could take a deep dive into classification models, clustering models, forecast models, outliers, time series, and their impact on supply chain AI. The other popular machine learning algorithms that are currently in use in industry are random forest, generalized linear model, gradient boosting, which is one level lower than XGBoost, but still nonetheless very powerful, and Prophet. Now we can see what Dataiku provides us with in terms of machine learning. And Nicholas can chip in as well here to explain what's going on.
Yeah, sure. So basically here the demo is showing that we're creating a project. And then we have to upload the first data set. So in terms of data set, Dataiku is able to connect to whatever kind of data source you want, from a SQL database, a Spark cluster, Hadoop cluster, cloud storage buckets. Then what we have just an overview of our data for inspection purpose.
We can add multiple data sets. Dataiku has a pretty strong infrastructure and can handle large amounts of data like we have seen just now.
So we have a question on the chat. Spark available only for paid version, right? Yes, indeed.
Now what we're doing here is essentially looking at each data set to see if the data is correct. we can split the data set. Instead of doing it by code, we can split whatever columns we want. For example, if we want a huge data set, instead of doing a pre and post on the same data set with code, we can simply use a recipe in splitting by what value we want and creating a new data set. Once we have that, we can go to our flow. Inside our recipe, we can like join with for example, if we have separate data sets that we want to combine, we can use inner join, external join to get the proper parameters that we want, because data sampling is pretty important when we're working with AI models, because like we saw today, XGBoost will not work with certain values and other models might not work with, say, integers or text inputs, which is why data sampling is a key initial step before we get into the actual model building. And with DataIQ, it's a pretty intuitive process. It's all visual, which really helps. Now we can actually do the prediction modeling, and we can choose what essential factor, like we did in our Jupyter code. Say, for example, if you want shipment value, we can then go into automated machine learning, look at quick prototypes and spin up a machine learning model in a quick instance. Now we can see here the actual values of what we saw in Jupyter, for example, our ridge regression or XGBoost regression. The training is pretty fast, and yeah, it generally works out to be pretty comprehensive. And then once we have built our model, we can then deploy it. As you can see here, we are using the prediction model. We click on it, and then we can predict on our post data instead of our pre-data. And then once we go back to our flow, we can see a nice view of a complete machine learning model in DataIQ. Anything else you'd like to add, Nicholas, about why DataIQ is really helpful?
Yes, absolutely. So the very first element is what you mentioned. You can use a visual aspect, visual object without any code. The code is generated in background. So we had a question related to Spark in the chat. DataIQ will generate the Spark code for you. So you don't need to have data engineers in order to develop that. Otherwise, if you have data engineers that want to code, they can code. People can share their insight, open discussion, and help themselves, because you need subject matter expert and data engineers and data scientists at the same place, so they will be able to contribute and share their insight into a dashboard. And the last point is, and not least, is the complete aspect for production and automation at scale, meaning that all the behavior of training, retraining, checking model quality, assessing the performance of the model is handling by DataIQ, and it supports whatever kind of engine you want. So basically you can learn on scikit-learn from Python, and you apply your model using Spark if you want, or GPU.
Personally, for me, DataIQ I found in my MLOps is that it's good for monitoring. It essentially lets us track and visualize drift over time for all models across the organization in one central location. It's super scalable. It leverages existing distributed storage and processing infrastructures like Nicholas mentioned in SQL and Spark. And we can also deploy and manage containerized services at scale. In terms of code and integration, we can build end-to-end solutions and services from scratch with the languages and tools we know and love, like R, Python, Scala, with DataIQ's SDK and the GUI. In terms of operationalization, I really love it because it helps me automate and personalize and monitor all my data pipelines in a simple flow. So in conclusion, actually yesterday I read an article in Bloomberg's magazine that the World Trade Organization reported that trade can decline between 13 and 32% in the next couple of months. We can't simply break and recreate supply chains at the drop of a hat. We need to use the tools in our repertoire to digitize and accelerate our supply chains. And in order for us to do that, we have to be proactive instead of reactive. A lot of data science teams' work have, again, been rendered redundant due to the pandemic. And hopefully through this workshop today, whoever's new to machine learning operations or XGBoost or supply chains have learned something of value that you can take back to your organizations or yourselves. And hopefully we've had a small contribution in teaching you something new today. Thank you for attending, and I hope you all have a wonderful night. Any other questions? We're taking questions right now, so please go ahead.
Are you going to post the links?
Yep, I will post the links right now.
Are they posted in the chat? Or?
Yep, they're posted in the Zoom group chat.
Oh,
it should be. Let me.
Oh, Srikar, I think you sent it to me directly. If you can send it to everyone, that'd be great. Perfect.
Hey everyone, just a quick note that we will also be sending the video as well as all the links after the workshops as well too. So we'll send it out tomorrow or the day after.
So just a question. I saw someone called Valerie posted a question, and I'm not sure whether you covered it or not. Apologies if you have.
Yeah, I can explain where I'm coming from. I am a senior data scientist at Cineplex. You know, this chain of movie theaters and other entertainment premises. So currently we are working on a family of models that may be kind of similar to one type of models you're also working in the supply chain. This is, we call it attendance forecast, and you've been working on demand forecasting models, right? So they're kind of similar. My question is, have you noticed any changes in customers' behavior or any kind of new data patterns in post-COVID data sets so that it has a negative influence on the performance of existing models? So that maybe you come up with any ideas what to do with models right now or in post-pandemic world.
I can handle that one. It's Eric Buckingham here. So the purpose of, I think, retraining the models on the post-COVID data helps to leverage, of course, the new normal, right? So pre-COVID, of course, the universe was very different than it is today. And this is how, MLOps and this automated pipeline that DataIQ has helped us build helps to ensure that the new normal, the universe that we're training this machine learning model on, is based on the current reality. And post-COVID, because the universe is changing every single day, right? As we come out of the lockdown, of course, the universe will be represented very differently by this training data. So the frequency of retraining needs to be increased, and we believe that the impactful features need to be augmented. So things that mattered before might not matter today. And of course, you might be able to augment your data sets with new and interesting and novel features that you might not have envisioned before. Just one last thing that I would mention is with regards to physical and virtual supply chains, because we're digitalizing the supply chain to a massive extent. Great example is Walmart or any retailer is integrated with fintech companies for facilitating payments, right? So an attack on the virtual supply chain, so basically packets coming across an IP network, would affect that fintech provider that integrates with Walmart's systems, thereby possibly taking down that retail sector corporation, right? And then of course, physical sector corporations that used to basically exist just in the physical realm are now highly digitized, thereby emphasizing the fact that we very much need to focus on those virtual supply chain risk objects, where maybe 5-10 years ago we didn't have to do that as much. But absolutely, those are some of the key things that we've learned recently, and specifically around cyber threats. We're seeing a lot of impacts on the virtual supply chain during COVID from things like malware and ransomware. So great question. Anything else?
Thank you.
You're welcome.
So if I understood that correctly, you're focusing more on retraining existing models, but right now you see there's no real push to either reinvent or tweak existing models.
So like I mentioned, a lot of the things that mattered before might not matter today, or new things might matter more. So feature engineering on new data sets that are relevant because of COVID, and coming out of COVID, of course, we're going to find new and interesting ways to add additional features to make our models even more relevant with the new normal, right? So I'm being very general here just because the world is changing every single day, right? Like just today in Toronto, we can now sit on patios, which is great because it's so sunny out. So that's going to absolutely change the structure of our society and the mobility of humans, and how we aggregate in groups. So absolutely, every single day, our realities and things that we take for granted are changing very quickly. And the frequency of retraining a model needs to be almost daily. Some of the use cases in data science lend themselves very well to a very frequent retraining. Things like preventative maintenance on, say, like a chip plant, right? A manufacturing facility somewhere in California or Asia. Those models could be retrained on the order of every 20 to 30 minutes because of the volume of data that the training data is ingesting. So for the use cases that we've looked at today, I think a daily retraining at most would be relevant. But depending on the amount of data that you're consuming through either streaming data or your existing data sets, I would definitely recommend that you're retraining on at least a weekly basis.
Yeah, and feature engineering becomes the priority #1, I guess. So
absolutely.
Like
so yeah, absolutely. Great question. So just one last thing on the virtual supply chain, there's a massive treasure trove of data in your data center, and your cyber fusion teams have a lot of good data as well that you can use to model supply chain disruptions, and that's where we're mostly focused right now. So I would definitely recommend that you take a look at that use case.